Welcome everyone to another interesting topic on drinking water contamination. I'm your host, Dr. Yasir from Olympian Water Testing, an exclusive New York City and New Jersey based water testing company in the United States, and today I am going to update you about manganese contamination in drinking water that possesses high biological significance to human body. However, its levels should be monitored in drinking water because elevated and prolonged exposure to manganese can be a cause of concern to human health. My today's video will try to answer some major questions on drinking water contamination of manganese, including its occurrence in the environment, major sources, regulations, health risks, and detection and removal methods to keep your drinking water safe from manganese toxicity. The contents of my video will try to cover the background information on manganese in drinking water, its major sources and routes through which manganese can enter in the drinking water systems and contaminate it. Next, I will update you on the regulatory status of manganese in drinking water in the United States, followed by a brief description on various health impacts associated with manganese exposures. I will then describe some known quantification or detection approaches of manganese, followed by different recommended methods for manganese removal from drinking water to make it consumable for humans. Finally, I will give you some recommendations to keep yourselves and families safe from drinking water associated manganese exposures. Manganese is among the most abundant elements on Earth that occurs in the form of various rock minerals in soil depending on the geological composition of the regions, in water, particularly the groundwater sources, and in dissolved form as manganese ions or as colloids in sediments and biological systems. In drinking water, its occurrence is mainly dependent on regional geology and proximity to manganese containing rocks and minerals. Manganese gets enriched in drinking water systems through natural and anthropogenic sources. Some notable sources of its enrichment include geological formation, leaching, and runoff processes, whereas the anthropogenic sources include industrial activities, municipal distribution, and water treatment systems, etc. In general, the drinking water manganese concentration may range from very low to high. Manganese contaminated drinking water can have both environmental and human health impacts. Therefore, its monitoring in drinking water is essential to ensure manganese-free drinking water supply to the consumers. Talking about the regulatory status of manganese, in the United States, manganese can be present in drinking water sources, especially in regions with geological formations and industrial activities. The US EPA has established a secondary maximum contaminant level SMCL of 0.05 mg per liter or 5 parts per billion for manganese in drinking water to address the aesthetic issues associated with manganese, including discoloration and taste. However, these guidelines may vary among states as different states have set their local MCLs for manganese based on its occurrence in drinking water. Furthermore, manganese also shows chemical synergies with other metals, especially iron. Due to the reason, it is recommended the concentration of both iron and manganese must not exceed 500 micrograms per liter in drinking water. For more details on manganese and related information, I have provided following EPA URLs where you can find up-to-date details on manganese in drinking water. Water with elevated manganese level has a brown to black appearance, making it aesthetically unfair for drinking purposes. Manganese possesses high biological significance to the human body due to its essential role in many metabolic reactions. Due to the reason, its low concentration detected in drinking water do not pose any serious health concern to humans, therefore considered unharmful. However, health concerns arise when the manganese is taken in a high concentration and for a long period of time, which may result in some serious health problems. For example, various studies have reported neurological effects among children and infants exposed to high manganese levels, resulting in developmental delays, cognitive impairments, and motor coordination problems. It is important to mention that the exact threshold level for manganese have not been set so far due to individual variability to disease susceptibility and demands extensive scientific research and debate. As mentioned, the manganese levels detected in drinking water are not a general cause of concern. However, regular monitoring of public and private wells for manganese can ensure its safe supply to the consumers as well as may help in establishing threshold biological limits of toxicity to humans. In addition to neurological effects, some other health implications have also been associated with elevated manganese intake. These include cardiovascular, respiratory, and reproductive disorders and manganese toxicity with symptoms including muscle tremors, insomnia, hearing problems, loss of appetite, depression, irritability, headaches, and weaknesses have also been reported. However, the evidence in this regard is weak, and particularly in the context of drinking water exposures and associated health effects, with lacking epidemiological evidence so far to address the health issues. Manganese can be quantified in drinking water using various methods depending on desired results, sensitivity, technical support, and availability of suitable instruments to analyze the water sample. The methods range from simple field tests to sophisticated analytical platforms. Some commonly used methods to analyze drinking water manganese include simple and cost-effective colorimetric test kits for on-site measurements. These kits involve the addition of a reagent to a water sample that results in a color change proportional to manganese concentration in drinking water. Electrochemical methods are also commonly used for the detection of manganese in a sample. The method is based on the application of a voltage to an electrode, and the current response is proportional to the manganese concentration, which can be used for quantitative analysis. For more sensitive and accurate detection of manganese, atomic absorption spectrometry (AAS) is most commonly used technique capable of quantifying manganese at low levels with high precision and accuracy. This method involves the measurement of light absorption by manganese atoms in a water sample. Inductively coupled plasma (ICP) coupled with optical emission (OES) or mass spectrometer (MS) is also a widely used analytical technique for manganese quantification and is capable of detecting manganese in drinking water at parts per billion levels. The detected manganese levels in drinking water can be removed using various developed methods. Some known approaches include oxidation and filtration, which involves the conversion of soluble manganese ions into insoluble manganese oxide using chemical oxidants, followed by filtration to remove manganese particles. Coagulation and filtration involve the use of coagulants such as aluminum sulfate, alum, or iron salts that coagulate manganese in drinking water, which is then filtered using suitable filtration system. Ion exchange resins also work effectively to remove the dissolved manganese in drinking water, in which the manganese ions are captured on a resin bed and removed from the water. Biological filtration involves the use of certain bacteria capable of oxidizing dissolved manganese in the water and is effective in removing low to moderate manganese levels in drinking water. The most widely used method for manganese removal includes reverse osmosis due to its wide applicability to remove a range of environmental contaminants from drinking water. It is highly recommended that you should conduct a routine monitoring of drinking water in your house from certified professionals. In case elevated manganese levels are observed in your drinking water, it is highly recommended to remove its contamination using a recommended removal strategy. Further, you must ensure to trace and mitigate various sources that can potentially contaminate the drinking water system of your house and workplace, and make sure to replace or clean the water pipes and plumbing every 5 years. This is all about my video on manganese in drinking water. I hope that the content of my video will greatly help you understanding basic concepts on drinking water contamination of manganese, its associated health impacts, and how you can avoid or reduce the exposure in your household drinking water. However, if you still have any query, please don't hesitate to reach us at the following telephone numbers and we will be pleased to respond your queries. Thank you very much and goodbye.